friends and listeners. In today's episode, we are excited to have our guest, Mr. Eric Allatta. In 2012, he earned a master's degree in urban adolescent education from Hunter College. He has been a teacher since 2003, mainly in the subjects math and computer science. At the Academy of Software Engineering, he has been teaching since its establishment in 2012, and he played a very crucial role in starting the school. He is currently designing a ninth and 10th grade computer science sequence based on the Bootstrap curriculum family that culminates in the AP Computer Science Principles exam. Eric, welcome. We are
Thank you.
excited to have you on our show. Let's talk computer science.
Very happy to be here.
So, why did you choose to become a teacher?
I'm thinking about that question very deeply right now. Right now in my life is a little bit of a sad story. Uh, this year, both of my grandmothers passed away. And I bring that up because both of my grandmothers were teachers who had very strong influence on me. And I think when we choose what to do, when we choose what to be a professional at, we know how to do certain things because we see it with our family or people who influence us. I grew up knowing what it meant to be a teacher, and when it was time for me to choose a career, that's what made the most sense to me. It was like it was uh, in me. I love lots of different things. I love doing things like building things and making things and playing music, but teaching is what I understood from a very early time.
I'm so sorry about your both grandmothers. I, I mean, hats off to them. They have influenced so many people, and including their own grandson. So, tell us about your school.
So the Academy for Software Engineering was started in 2012, and it was a partnership between the city of New York and a very influential technology venture capitalist. Wanted to create more programmers that come from New York City, trying to grow the technology sector, and it needed more people. It needs more engineers. And most of the engineers that work in New York City didn't go to school in New York City. They didn't come from New York City public schools. There are some programs in New York City public schools that are uh, producing computer science students, like the program at Stuyvesant High School. It's been there for a very long time and produces very good software engineers. But to get into Stuyvesant High School, you have to be one of the best students, and you have to pass a very difficult exam in 8th grade. So this idea was, well, we want to create a school where everybody will learn computer science, but we don't want that school to be a school that's difficult to get into. It should be a school that's open to everyone. Now, when the school began, there was a whole bunch of people, like uh, people from the software industry and people from colleges in the city, people who are real big shot computer science people. And they said, you should teach them this. You should teach them relational databases. You should teach Java. They told us this is what you should teach. And over the past 9 years, we've learned what it means to be a computer science academy for all students, where there's no screening or filtering that leaves out some students. And that's how we got started. That's still what we aspire to do.
Can you elaborate more on that? What does Computer Science Academy for all students mean?
I don't know if your listeners are familiar with New York City and the New York City school system. It is considered the most segregated school system in the country. If you live in a certain neighborhood, you go to certain schools, and it's very school you go to and what opportunities you have is very much depends on where you live and where you grew up within the city. When you're an eighth grade student in New York City, you have to choose your high school. And New York City has a kind of a lottery system where you can select different schools and you have a chance of getting into them. Some schools you have to pass a specialized exam. Those are called the specialized high schools, like Stuyvesant and uh, Bronx Science and Brooklyn Tech. And those are very competitive high schools that where the students go to elite colleges. There are other schools where you might have to do an application or have a certain attendance, or you have to get a letter of recommendation. There's different schools that have different requirements. And then there are schools that don't have requirements. They just anybody can apply and get into that school. So the Academy for Software Engineering is one of those schools. When we started in 2012, we were considered a limited unscreened school. You did get more preference, more weighted preference if you lived in the Manhattan borough. So 50% of our students came from Manhattan borough. Now we are now an open enrollment school, so actually all boroughs are now equal weight. There's been some slightly different enrollment models. Like we last year we were part of an enrollment program that tried to distribute uh, uh, grades like evenly. So you got an even distribution of different higher grade earners and lower grade earners. So we've had slightly different models, but the basic idea is there's no testing requirement or special attendance requirement, or there's no requirement to get into the program. You just have to put us down on the list of schools, and if you put us at the top of the list, then you get a chance of getting in. We only enroll 120 students per year, and we get about 3,000 people to put us on the list. So it's still not like it's not a very good chance you'll get in. Uh, but all you have to do to get a chance to get in is to put us at the top of the list of your high school choices.
Then how do you take only 120? What if when 3,000 students are putting your school on the top of the list? Or maybe at least 500 students.
No, we are a small school. We are a school within a big building, which was created by the previous mayor of New York City, Michael Bloomberg. You know Michael Bloomberg, the big technology guy. He broke up the big schools. So our high school building is called Washington Irving Campus, but the Academy for Software Engineering is the fourth and fifth floor, uh, not even the entire fifth floor. It's half of the fifth floor of that building, and it can hold about 450 students. So each class is about 120-ish students. We get 3,000 applications, and then we are randomly given 120 uh, by the city of New York. The students put down where they want to go, and they submit that to the city, and then the city assigns students a school. They try to assign
Okay.
students the school that's as high up on the list as they can, but it's basically a lottery.
So tell us about your role when the school was getting started.
In 2012, when I was applying to this school, I was graduating from the Hunter College program, you know, looking for a, a chance to teach math, or I wasn't even really thinking about computer science. I don't have a background in computer science. You should know that. When I was in undergraduate college, I studied philosophy and history, history of math and science. in linguistics. I didn't study computing, but when I was getting my master's degree, I was very interested in doing the mathematics through computation. It was appealing to me and it made sense. Like, lots of the things that we teach in mathematics are computational ideas, and it's a lot more fun to do them on a computer sometimes than it is with a pencil and paper. So I was getting into the teaching workforce in New York City, and I saw that they were creating this school. A friend of mine knew somebody that was going to be one of the people I went to school with knew who the person that was going to be the principal, and I was very interested because I wanted to teach math in a different way. I I wanted to be a math teacher, but I didn't want to be teaching in exactly the same way that it had always been done. Using computing, there's so many more fun things to do. Before I became a teacher, I worked for a woodworker, like in a wood shop, like building things with wood. I would like to teach all students how to build things. I can't teach them how to, I can't give every student a chisel or a hammer, but I can give every student a computer. And so in my mind, I'm actually teaching how to make things and how to build things and solve problems, but I'm doing it with a computer because that's what needs to be taught. So that's sort of how I got into wanting to be a part of the school. And there was a computer science teacher who was like had been teaching computer science for a very long time, and I was the other person who didn't have a lot of computing experience, but was very very energetic and passionate. And I said to the principal, I want to work for your school. I won't say yes to any other school until you tell me yes or no. I really want to be there. And that was what told the principal, okay, that he wanted me on the team. But still, I didn't have the background like the other guy did. Now, after the first year, the person who had the experience teaching computer science did not work very well with the population of students that we work with. He found he had very combative relationships. We've learned that knowledge of computer science is important, but there's a lot more to doing what I do than knowledge of computer science. So I am a founding teacher. I have been there since the beginning. I've taught math classes and computer science classes all across our program as we grew. And I'm somebody that cares very much about teaching the population of students that we work with, and to design experiences that really help students and meet them where they are.
I love it. I like this quote. Knowledge of computer science important, but there's a lot more to teaching. Should cater to the students who you're teaching, right?
Yeah,
Yeah.
I think we'll talk about this in a little while, but I'll talk a little bit about what I'm doing this year in our very
Mhm.
extraordinary year that is trying to meet my students where they are.
Yeah, let's get to that question. So, how do you teach technology in the classroom today?
So, computer science teachers really care about programming, right? Writing programs, that's like supposed to be really important. Um, I have not done any writing of programs this year. All of my students are remote. We are not in the school building. I don't have the same technology set up for every student. Some of my students are doing all of their school through a smartphone. Many of my students are doing school through an iPad with no connected keyboard, like touching on the iPad screen. Can you imagine trying to type programs that way? So there are other programming languages like Scratch where they could drag things onto their screen. But still, my students are struggling for lots of reasons. They are home now, and most of their parents have to go to work, have to leave the home to go to work. My students need support with with keeping track of their schedules, learning how to take ownership of their learning for other classes and find connections, learning how to process their email and like keep themselves like in touch with information without getting overwhelmed by information. So this year, my focus has really become digital communication and information management. But what I'm thinking about is programming.
What you just said is technology as well. What is part of computer science
I
too?
think so. I think so very much. And I can see now how I'm teaching those concepts. But I used to think I could only teach those concepts by teaching writing a program. So the first thing we did this year was starting to develop student websites. But I haven't taught them any HTML or CSS or anything like that this year. I just want them to create. So the first thing we did was just starting with Google Docs, create web pages using Google Docs and use the functionality to publish your Google Doc as a web page. And then we started to look at when Google Docs publishes the web page, it produces this thing called HTML. So we started to look at like, you can kind of look at how does the HTML match up to what was produced. But my goal was just to get all the students making something. Student or portfolio websites, that was good because they can do their other class work, and they could like put their history class onto their website, and then I would give them credit for that. This year it was very important to me that all of the assignments and learning that we do in computer science had to also help them in other classes, because if I'm just doing another class adding on another set of concepts and skills, I would really miss most of my students. My attendance last semester was 63%. So some students came only once or twice. Some students were very regular attenders, but the students are not they're not able to manage all of the work that they have to manage being home alone by themselves. So the second thing was so portfolio websites. The second thing is called computing in the news, and I learned about that many years ago from the Beauty and Joy of Computing curriculum. It's a wonderful idea. You just begin the class by looking at current events. I have students go through a page of headlines about technology and choose a headline that they found was interesting. And then we spend a few minutes talking about that article and what are the basic ideas in the headline. So these two things I want you to actually stop and think about. Creating a Google Doc and reading a headline and making sense of it. Those are two skills that my students don't have coming in. I cannot assume that students can just create a Google Doc and format it to look good. Students know about Google Docs, but mostly teachers give students pre-formatted Google Docs, things that they've already made, and then maybe the student has to fill in a box. But starting from scratch and starting to develop something like that has a title, that has some organization, that maybe uses a table to lay things out on a page, those were skills that we were developing for the first time. Reading just the headline of an article and making identifying words that we didn't understand and putting things into context, those were skills that students don't have necessarily coming in with. So we talked a lot about artificial intelligence and making the connection between artificial intelligence and machine learning, and just what do we mean when we say artificial intelligence? That came up a lot just in talking about different articles. Artificial intelligence is like one of the number one topics that we're going to see. So what we're really wanting to talk about with students is like, well, what does it mean to learn from data and to make predictions using data? How could we make predictions using data that we have available? And then the third thing that I have been doing this semester is helping students to really understand their Gmail. Like, so how do you query certain ranges of time within Gmail? How do you process your inbox so that you're assigning a task for for every email? deciding what to delete, deciding what you need to follow up on, adding some layer of organization to the information that we are expecting students to have right away. And again, my students don't come in to ninth grade where you can just expect that they can process their own email. I didn't learn how to process my email until I was much, very old. So now we're expecting a 14-year-old or a 13-year-old to just be able to manage their email, and they're getting 8 messages a day. My students had 700 messages from last semester that they never did anything with. They didn't know that they were supposed to be reading them and doing something with them. So those are the kinds of things that I've done to teach technology this year to make sure that I'm supporting students with what they already have to do and using the tools that they are already using. Then they can be more effective and less overwhelmed. And then at the end of this year, we're going to start programming together. But I'm not going to do any grading of the programming. I'm going to stop grading them in May. So my grade book will be done. They're all going to have, pass the class. And then I'm going to start doing some programming projects to expose them to writing some programs and try to do it in a very fun way that doesn't feel overwhelming. Uh, and yeah, I'll stop there. That's where my head is at when it comes to supporting students in this very crazy year.
Yeah, that's very interesting. Yeah, it's very creative, and you're also understanding your clientele and what they need and help them to be succeed in everything that they're doing, plus learning computer science. That's super impressive. That's amazing. So, so I skipped the questions. I'm gonna go back to the question. So, what is your school's vision and goal for next couple of years? I mean, if there was a pandemic, if there was a COVID.
Our goal for next year is going to be to have students back in the building, right? No, our goal for the next few years really are about the two big initiatives. One is called mastery-based learning, and the other is called culturally responsive education. So mastery-based learning is a type of curriculum and assessment that we've been trying to use. We started our transition to mastery 5 years ago, 6 years. It's been a while that we've been using a language for grading that is mastery based, which means that we talk about grades as skills, and assignments and assessments are just attached to the skills. So in my class, the skills. So I've really narrowed it down. The two skills this year are I can use computing tools and I can revise and reflect on my work. So if students are developing a portfolio website, I'll give them different assignments, like now add this to your site, now do this, right? But what I'm actually giving them a grade on is I can revise something. So I can develop a project over a long time by adding small things to it each week. And then I can write a few sentences that say what did I add to my project. So mastery based learning is a way of getting the conversation with students about skills and not just what assignments are you missing. It used to be you get 100 or a 0, 100 or a 0, 100 or a 0. What are you missing? But that doesn't help students to develop any awareness of what they're learning and why are they learning it, and what could you do to improve what you're doing. The second big initiative for the school is to be more responsive to where our students are coming from, and to be more sensitive to the students who are building an identity and may have come from marginalized communities, may have come from historically underrepresented communities, especially underrepresentation in computer science. So what we want to add is whenever we're talking about a topic in math or history, we want to also add to our curriculum, something that addresses the students and where they come from, something that addresses the power structures that we all live within, and something that kind of helps or at least prompts the students to think about their own identity. You know, who am I? How do I fit into this place? There are not very many people that look like me. Can I still be a part of this? Um, we would like to create better curriculum, and we would like to do a better job tracking students and like really using data to get into who students are and to track students and to help give students interventions that support them with what they need. That's my personal big project. Aside from teaching, I do a lot with the school's data. How everybody has a focus in computer science. We have the teacher who's
Mm-hmm.
really into maker spaces and 3D printers, and we've got the teacher that's really
Mm-hmm.
into creating web pages and video games. I personally really care about data. I want I want all the students and all the staff and teachers to have basic skills with spreadsheets, to be able to kind of uh, work well with data that they're given, and to be able to build data sets that actually help people do their job.
Yeah, data is very critical, and it is growing. We all are analyzing data to make any kind of decision. So that will be a extremely good skill for this, for your
Yeah, and
students.
schools are not good at data. Like there's teaching the students more about it, uh, but also schools will have like two different spreadsheets that are slightly different formats, and then they're like, oh, we can't use that data. It doesn't we can't match it up. So we need to increase just the general data knowledge across the board. But schools desperately need help with their data.
Okay, so what is the best product, if you have used any product to teach technology, and why is it good? Based on everything you said, sounds like you create your own
Oh,
content.
so in the introduction that you read for me, it talked about the Bootstrap family of curricula, and I've actually not done very much with Bootstrap this year because this year is a very different year. But every other
Mm-hmm.
year, Bootstrap is what I go to for the kind of the core of my teaching and curriculum. So what Bootstrap is, pedagogy and a curriculum for teaching computer science, but it is designed to be taught in math and science classes. So I want to teach computer science in a way that is relevant to what students are learning in other classes. So I feel pretty strongly that if students are learning algebra, then teaching them procedural programming in ninth grade is a bad idea. We want to use computer programming languages and computer programming tools that line up with what students are already learning. So, algebraic programming, functional programming in languages like Pirate, Scheme, uh, those are the tools that I choose when I'm teaching programming. And I teach it in a way that maps onto and also with when I'm teaching data and data programming, which I use Pirate for. It needs to line up with the way that they're already thinking about functions and the way that they're already learning to kind of begin to think computationally in their science classes with data and in their algebra classes with like solving problems and designing functions.
My last question is, if you could use one wish to help enhance the technology in the K-12 education system, like when I say technology, like teaching technology, what would that be?
Right. So, what I was just saying about how I think computing education, especially for like eighth and ninth graders, like early adolescent education, needs to be geared towards math and science. So like the biggest thing that could help is math and science being less less like yeah,
Intimidating.
well, so math and science teachers are very set in their ways because the tests that they have to prepare students for are very are present math in only one way. So they need to make sure they need to like even using a programming
Be
language that looks
flexible.
similar is like not that they can't
Yeah.
do that because it's like it's too different, even if it's a little bit different. Uh, so we this is a my question my answer to your question is not going to be straightforward because we need math and science to evolve to incorporate computing. But the problem is the way that this is like people are trying to get involved is with this technology mindset of disrupting, and you end up with these charismatic uh, technologies that look like they're really good, but they're not thoughtfully aligned to the concepts that students are already thinking about. Right? It's more about like people in the technology industry thinking that everybody should learn like they did, and they should use tools that are the same as what they're using in the industry. That's just wrong. You should not be using industry tools to teach beginning students. Uh, the the difference between when they are going to become a professional and when they are just beginning is so far that you should not think you have to prepare them by teaching a language that is like in vogue in the technology industry. So we need math and science to evolve, but we don't necessarily need big tech to come in and tell us what the solution is. And that is a problem that I don't know how to like I don't really have any idea what could help that. But that's where I am. I feel like I'm kind of in the middle. I think that if we want all students to really get a better foundation, we need to do it through the classes that they're already taking. And it needs to be concepts and skills that are aligned to what they actually need. Uh, Not pie in the sky, not like, oh, you're all just going to become software engineers next year. It needs to be realistic, and it's not going to be as flashy. It's going to be something that's more rooted. It's easier to assess and like know what students are really learning, and it's going to require like a combination of technology starting to get it and being like less trying to disrupt and being less like charismatic and like we're just gonna just stop doing what you're doing and do what we're doing. Technology needs to stop doing that, but also we need traditional instruction to evolve, and changing traditional instruction is going to mean changing the tests because teachers teach to the test, and it's that reality is not going to change. So how are we assessing and what are we expecting students to know? That's what needs to change at the same time.
That is very thought provoking, everything you've said. Thank you so much for being bold and giving, telling like one way to solve this issue. And probably this is a long shot, but I think this is the best way to teach more computer science. Thank you so much, Eric, for your time. If you would like for listeners to reach out to you, where would can you tell us like how people can reach out to you?
Oh, sure.
It's a completely optional
Yeah.
question.
I'm happy to have anyone reach out to me through my email address at the Academy for Software Engineering, Allatta at afsenyc.org. It would be great to keep up the conversation with anybody out there who's listening.
Thank you, Eric. Thanks a lot.
Thank you. It's really a pleasure.